With our AP statistics class P3, and we're going to be going over some questions about probability models. So this first one, number one is asking about a biology professor that receives a certain number of emails every day. So it looks like the only potential number of emails that he or she could receive is 0, 1, 2, 3, 4, or 5. Okay, and it gives you the respective probabilities. So how do we find the emails that we should expect the professor to receive in a single day? Yes, please. Yeah. That's right. I'm going to fill in some blanks there. But yes, we multiply the number of emails, like the possible number, times the probability that goes with it. Do that for all of them and then add them together. All right, so let's write that down. Do you remember what that's called? Expected value. Very good. So I'll use a capital X, but you can use whatever capital letter you want. You can even use E for emails if you want. All right, so we have 0 times whatever.
No, because I felt it.
Now, what if I receive this kind of question on the AP exam? Am I showing all this work?
No,
I'm not, right? I'm going straight to the calculator. And whether that means you're typing in what I just wrote, or what could you also do? Put it into two lists, which is what we're going to do right now. So if you have your calculator out, you can turn it on. All right. So where do we go to first?
List.
Actually, I'm going to hit stat.
Okay.
Stat, edit. So stat and edit. And I'm going to type in my possible number of emails that the professor could have received each day. So 0 through 5.
Wait, so they only need one more?
In list 2, we're going to write down the probabilities. So 0.05. Be a good time capsule. You already typed them in? Excellent. Was it you that typed them in, or was it somebody in my other peer that did? Yeah, I see. You're good. Some people just have it, they just leave it there. No worries. Okay. So now I'm going to go to stat, go to calculate. All right, so stat over to calculate. And we're still just using one variable, statistics. All right, so this is the same button that we pushed many, many, many months ago, earlier on in this semester. So hit enter. But the new thing that we talked about before Thanksgiving is that in list 2 is where I have my probabilities. So where it says frequency list, I'm going to put list 2. So I hit second number 2, which is list 2. And then hit calculate. All right, so what is the expected number of emails that I expect this professor to receive each day? 2.95 is correct. Very good. Now, we talked about this right before Thanksgiving, right? It can be a little bit weird to see 2.95 emails. Is there a way to get 2.95 emails? No, you're going to get 2 or 3, right? So really, like if we're saying this in terms of society, how I would speak about this is I would say, I expect this professor to get 3 emails a day, right? Just a slight round. Almost 3, right? Very close. Thank you. I appreciate that. Oh, it's chapstick.
Very
Okay.
cool.
Gosh.
This is very cool. This is awesome.
Remember, you can put thumbs up here at this moment. Okay. Letter B. How do we find the standard deviation? We just look, right? It's already in the calculator. I'm going to show you the work. All right, I'm going to write it all out. But do you have to do this? No. All right, I'm just showing you how you would do this by hand if you wanted to. I'm not going to do it by hand, but I'll show you kind of the workaround that I do. So I'm going to find the variance first, which if you forgot from before Thanksgiving is the number of emails, so 0, minus your expected value. We square that difference, right? Remember, that's nothing new there. But the new part is multiply it by that corresponding probability. All right, do that for all of them, and we'll find the sum.
Can we not write this part down?
I did say you don't have to do it right now. Yes. No worries. Remember, this is a college course, so whatever you don't want to write down, I am not offended. Right, but as I would tell my friends in lectures, if you're not going to pay attention and take notes, just go home. I mean, you can't right now, Thomas, but in college, feel free to do that. To not go to class? No, it's not a good idea. All right, now, I know it took a while to write it all down. All right, hopefully you see the pattern here. It's just each time I'm doing the number of emails minus the average, minus the expected value, square that difference times the corresponding probability. Okay, now I know what this number is. Here's how I'm going to find it. In your calculator, you have the standard deviation, right? It's right there. There's a standard deviation. So what I do is I'm going to square that number, okay? So let's see. Who has the number in their calculator? Do you have it, Joseph? All right, somebody. Go ahead, Thomas. You were ready.
1.321930.
Okay, wait. 3219.
3040.
Yes? Okay, so I'm going to take that number and I'm going to square it, right? Because if I square the standard deviation, that is my variance. So I'm going to do that. So 1. I always try to not round until I find the variance. So that's why I had Thomas read off all the numbers. It's not like a huge deal, Joseph, but just a good practice in life when you're using, because at some point you're going to be doing math that's like important to your life. This might not be, all right? But you want to always wait to the very last moment to round. Okay. Exactly. So we have 1 point. I'm going to approximate this to 1.75. 1.75. All right. So when I do that, that's 1.75 emails squared. Right. So I don't want squared emails. So I'm going to take the square root of that. So the standard deviation. I definitely don't want that. Is the square root of 1.75, which you already know, 1.32 emails. Sorry, wait, I'm waiting.
So why didn't we square it when we already got it?
It's because it's not going to be necessary in this moment, but there could be, let's say there was a part D where it was asking me to say what would be the standard deviation for the number of emails that he would receive in 5 days. So like Monday through Friday. Then I have to add the variances.
The example for a friend on their yesterday.
Mm-hmm.
I ended on the video.
Nice. You already watched it?
Unfortunately, I didn't.
You mean fortunately? I did.
All right. Part C. Part C. It says, if it takes the professor an average of 10 minutes to respond to each email, wow, that's a long time. Okay? How much time should the professor expect to spend responding to student emails each day? I think we can answer this without stats, just like logic. We can just read it. All right. How many emails do I expect the professor to receive from students each day? Essentially 3. And if it takes 10 minutes per email, how much time should he or she allot?
39.5.
I'm going to say 30 minutes. But yes, it's 10 times 2.95, so approximately 30 minutes. So to go back to your original question, Thomas, I'm not doing this if the question just said find the standard deviation like on the AP exam. I'm just doing this because I want you to know that you might need the variance, right? The variance is critical sometimes to answering some of these questions. Okay, everybody good with one? Now, number two is actually similar to a problem that we did on the homework before Thanksgiving. We had that problem about how much it would cost to take care of a dog or a cat. All right, so it's actually the same problem, but it's changed a little bit. All right, but the beginning is the same. All right, we're saying the annual cost of medical care for dogs averages $100 with a standard deviation of $30, and for cats, it averages $120 with a standard deviation of $35. So, find the expected value for the annual cost of medical care for a person who has one dog and one cat. So that's dog and cat. So how much are we expecting the dog to cost? 100. The cat?
120.
So we're writing $220. Pretty much every one of my students will get that right. Okay? Part B is where students start to miss it. All right? It says to do the same scenario. So the person has one dog, one cat. Find the standard deviation. So when I see this question, right, to find the standard deviation of two different random variables added together, I should be thinking about one of my tattoos. Variance is add, right? I think, what did I say it was? Here, right? The bicep, right? Gosh, just working on the biceps, right? Variance is add. See, it works all day. Okay? So variance is add. So you're going to see, Thomas, that they're giving us the standard deviations, but I'm only going to be working with the variances. Okay? So let's find the variance of dog plus cat first, and then we'll use that to find the standard deviation. So that's going to be 30 squared plus 35 squared. All right, so what is that? If you take a moment to type in your calculator. Excellent. Do you know what my units are, Victor? Oh, so close. Dollar squared or square dollars, or both are acceptable. Right, because we're dealing with variances. Do I want square dollars? No, I do not. I wish. Yeah, I agree with you, right? I wish, but we need to take the square root of this. So the standard deviation for dog and cat is the square root of 2125, which is, I think it's 4610. Yeah, let's make it money. Yeah.
So working with standard deviation, we think of squaring the average.
Squaring the average.
Yeah. Oh no, not square the average.
Squaring the standard deviation is the variance.
Yeah.
So you want to deal with variances. So if they give you the standard deviation, they'll usually give you the standard deviation in the problem. You got to square the numbers to deal with variances. Okay. Now, we did this problem before Thanksgiving on the homework, and the question said, what's the standard deviation for the difference in owning a dog and owning a cat? And does anyone remember what the answer was? It's the same. Because even if you're doing a subtraction of random variables, you still add variances, no matter what. Okay? That's how they're going to get you on the AP exam. Okay? So make sure you're always thinking variances add, always, even if it's subtraction. Okay? Everybody good? Okay. One more extension here. Now we have a couple who owns 4 dogs. All right? That's a lot of dogs. Okay? So if we want to find the expected value for dog and dog and dog and dog, I'm going to take, I think it's $100, right? And add that together. So there's 4 of them. So what do we think is the expected value for the annual medical care for these couples' dogs? 400. Again, most students will get that right. But here's where they get it wrong. The next one says, what's the standard deviation? What should we do? Add the variances, right? That's all we're going to do. The variance is add. So I'm going to find the variance of dog plus plus dog plus dog. All right, which is going to be 30 squared plus 30 squared plus 30 squared. Ah. Well, just 4 of them, right? All right, so that's 900 plus 900 plus 900 plus 900 for 3,600. There we go. And again, this is square dollars. Oh, you know what? Oh, let's be fun here. Let's put the dollar sign and then we'll square it. Oh, sick. Gosh, that was so much fun. Thank you for being here for this moment. Okay, and so the standard deviation for dog and dog and dog and dog equals the square root of that. And what's the square root of 3,600? It's $60. It is. That's it.